Router Static Routing Configuration Master, the configuration methods and techniques of static routing. Master the implementation of network connectivity through static routing. Familiarize yourself with the connection methods of wide area network cables. This is the experimental background. The school has 2 campuses, one old and one new, each operating as an independent local area network, LAN. In order to enable proper communication and resource sharing between the 2 campuses, a router is used as the gateway for each campus. The school has also obtained a 2 Mbps dedicated digital data network (DDN) line to connect the 2 routers. It is required to configure the network appropriately to achieve normal mutual access between the 2 campuses. From a technical perspective, the routers belong to the network layer devices and are capable of selecting the best path based on the information in the IP packet header to forward the data packet. They facilitate communication between hosts in different network segments. Routers use routing tables for route selection and forwarding, which are composed of individual routing information entries. There are 2 main methods for generating routing tables: manual configuration, known as static routing protocol configuration, and dynamic configuration, known as dynamic routing protocol configuration. Today, we will mainly focus on static routing. Static routing refers to routing information that is manually configured by network administrators. In addition to being simple, efficient, and reliable, one of the advantages of static routing is its high network security and confidentiality. The default route can be considered a special case of static routing. When data is being forwarded and no matching route entry for the destination is found in the routing table, a route is specified for the data. We will discuss this further later on. Specific steps of the experiment. 1. Create the topology diagram using Packet Tracer, including 2 routers for the old campus, R1, and the new campus, R2. 2. Configure the IP addresses for the new interfaces on routers R1 and set the clock rate for the serial interface. Remember, it is crucial to configure the clock rate on the serial interface, even if you have correctly configured the IP addresses. Communication between the 2 routers will not work without the clock rate configuration. View the directly connected routes generated by the routers. Configure static routes on routers R1 and R2, and verify the static route configurations on both R1 and R2. Set the default gateways for PC1 and PC2 to the IP addresses of the router interfaces FA1, 0th, meaning that the default gateways for PC1 and PC2 will be set to the IP addresses of the router interfaces connected to PC1 and PC2, respectively. Test whether PC1 and PC2 can communicate with each other. If they can, it indicates that the experiment is successful. Next, let's take a look at the devices used in the experiment. We have 2 PCS, PC1, and PC2. 1 router PT, a scalable router. 2 switches. DCE serial interface cables. Straight-through cables. And crossover cables. These devices form the topology diagram. On the right side of the diagram, we are simulating the new campus, while on the left side, we are simulating the old campus. The old campus is connected to the router through switches, as the same as the new campus. The serial interfaces of the two routers are interconnected, simulating the use of DDN dedicated lines. All right. Let's proceed with simulating the static routing experiment using the Packet Tracer software. First, let's find two routers from the Devices panel. We will use this router device. Duplicate it to add another one, and then name them S1 and S2. Next, drag and place two switches and two PCS. Now, let's interconnect all these devices. Select the appropriate cables. Connect the PCS to the switches, and then connect the switches to the routers. Pay attention to the type of cables used for the connection between the two routers. It should be a serial interface cable. Also, ensure that the serial interface type matches with the other cable types. Let's change the interface of PC1 to make sure it is connected to the router's F0, 0th interface. This setup should be ready for the experiment. Next, we need to configure these devices. First, configure PC1 and PC2. Set PC1's IP address to 192.168.1.2 with a subnet mask of 255.255.255.0 and the default gateway to 192.168.1.1. Once PC1 is configured, proceed to configure PC2. PC2 is in the second subnet, so set its IP address to 192.168.2.2 and the gateway to 192.168.2.1. Once the configurations are complete, the setup is ready. Now, let's try to ping from PC1 to PC2 and see if it works. Open the command prompt on PC1 and try to ping the IP address 192.168.2.2, which is PC2's IP address. Currently, we observe that pinging from PC1 to PC2 results in a timeout, indicating a lack of connectivity. How can we solve this issue? We can address this problem by configuring the routers R1 on the left and R2 on the right. We need to configure several aspects, including the IP addresses of both router interfaces. Let's start by configuring the router on the left, R1. First, enter privileged exec mode by typing N. Next, enter global configuration mode by typing conft. Rename the router to R1 by typing hostname R1. Now, let's configure interface fast Ethernet 0, 0th, F0, 0th. We use F0, 0th because this router is connected to a switch through this interface. Enable the interface by typing no shutdown. Assign an IP address to this interface by typing IP address 192.168.1.1, 255.255.255.0. Exit interface configuration mode by typing exit. Next, we will configure the second interface in TS2 0th. The 20th refers to the serial interface used to connect the two routers. We will configure an IP address for this serial interface, IP address 192.168.3.1.255.255.255.0. In this step, we need to perform an additional action. Configure the clock rate for router R1, clock rate 64,000. Don't forget to enable the interface using the no-shut command. To activate the interface, enter end. Now, let's move on to the configuration of the second router. Rename it as R2. Next, configure interface F0, 0th. IP address 192.168.2.1. Note that 2.1 is the default gateway for PC2. Then, configure interface S2, 0th, which is the serial interface. IP address 192.168.3.255.255.255.0. So far, we have completed the basic configuration of the two routers. The main configuration involved setting the IP addresses for the Ethernet and serial interfaces. Once the configuration is done, we can test the connectivity by pinging R1's Ethernet interface from PC1. You can test it by using the command ping 192.168.1.1. If the ping is successful, it means that the connectivity is established. Using the same method, you can also test from PC2 by pinging the gateway with ping 192.168.2.1, and it should be successful. However, even though PC1 can ping the gateway, it cannot ping PC2. At this point, we need to add a static route to enable communication. On the router R1, we need to create a static route. By using the command iproute 192.168.2.0 255.255.255.0 192.168.3.2. By adding this static route, we are telling the router that to access the 192.168.2.0 network, it needs to use the interface 192.168.3.2 to reach it. Alright. You can exit the current mode and check the routing table using the command shiproute. You will notice that there is an additional route with an S indicating that it is a static route. The router R1 is now fully configured. Next, we need to configure a route on R2 as well. Use the following command. iproute 192.168.1.0 255.255.255.0 192.168.3.1. Similarly, you can verify the routing table to check the status of this route. After configuring both routers, you can now go back to PC1 and ping PC2. Using ping 192.168.2.2, you should see that the ping is successful, indicating that the routing is now working as expected.